Hello students, today we'll complete part 3 of acid, base and salt, class 10 science chemistry. Let's start. Today we are going to learn the chemical properties of the acid and base. How chemically the acid and base behave with different substance, that we'll focus today. Here we'll complete a set of reaction. First reaction goes as reaction of metals with acid. Okay, how acid react with metal, that one we'll see. And the second type of reaction we'll see how bases react with metals. Okay, on third we'll see how acid react with metal carbonates and metal bicarbonates. On fourth we'll focus on how acid react with metal oxide, how bases react with non-metal oxide, and on the sixth reaction we'll see how acid and base react with each other. So this sixth reaction we are going to understand today. So the first reaction goes as reaction of metals with acid. Okay, now when metal, here you focus first, when metal react with acid, what they form the metallic salt and hydrogen gas, right? So metal react with acid and reactive metal displaces hydrogen from the acid. Acid is what? Acid is something that produces hydrogen gas. Okay, or acid is something that produces hydrogen ion. So what the metal do, if the metal is stronger than the acid or than the hydrogen, they can replace the hydrogen from the acid, and that hydrogen ion will combine to form the hydrogen gas. Okay, and with the counterpart it is able to form the metallic salt as well. So when metal react with acid, what we get the salt and hydrogen gas. Now hydrogen is what type of gas? It is a colorless gas. Okay, it don't have any odor, it don't have any particular characteristic color. So whatever gas is coming out, to identify it you have to perform a specific test for it. Now what test we perform for hydrogen gas is termed as pop test. Okay, now see what is that pop test is. Now if a matchstick is brought near the mouth of the tube, okay, containing the product of the reaction, then we hear a pop sound. Okay, so if you're bringing a burning matchstick near this hydrogen gas, then what happened, it produces a pop sound, and that is called the pop test for hydrogen. So in this activity you see what you have done, we have taken some acid solution in the beaker and there we have dropped some reactive metal. For example, suppose you have dropped some zinc metal. Okay, now when the metal and acid react, they produce salt. Okay, in the aqueous state the salt will be present here, and hydrogen being the gas will come out in the form of bubble. Now when you bring a burning matchstick and exposed it to the bubble burst, forming a or making a pop sound, and that is called the pop test for hydrogen gas. So you have to remember that hydrogen gas bursts with a pop sound. So what test we perform for hydrogen gas? We perform the pop test for hydrogen gas. So here you have to remember 2 points. First point is metal react with acid to form salt and hydrogen gas. This formula you have to remember, that whenever metal is exposed to strong acid, they produce salt and hydrogen gas, and to detect the hydrogen gas we have to perform the pop test, right? Next, 2 facts are given regarding this acid and metal reaction. First one says magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen gas. Okay, one example is given that magnesium is a reactive metal, so it reacts with hydrogen chloride and it forms salt, magnesium chloride salt and hydrogen gas. So no problem with it. Okay, in the next, see, they are talking about electrochemical series. Okay, so this is a recap of your class 8 and class 10 metal non-metal chapter. You know what is reactivity series is. In the reactivity series what we do, we arrange the metal in decreasing order of the reactivity. Okay, we start from the most reactive metal, and as we move down what we get less reactive metal. And what is the placement of non-metal hydrogen? The non-metal hydrogen you can see here. Okay, you can see the non-metal hydrogen present here in the reactivity series. So some metals are on the top of the hydrogen gas and some metals are on the at the bottom of the hydrogen gas, right? So metal that are on the top of the hydrogen gas are more reactive, so it can displace hydrogen from acid, okay, and the metal that are below hydrogen gas, it will be difficult for them to replace hydrogen from the acid. So that part is clear. Okay, now let's see. Electrochemical series is the development of a series of metals that are arranged as per their reactivity in a sequence from highest to lowest. Okay, as per reactivity we have arranged the metals. Copper does not react with hydrochloric acid. Okay, where is the placement of copper? Copper is below hydrogen, so it cannot displace easily hydrogen from a strong acid. Okay, because it is weaker than the hydrogen itself. So copper does not react with hydrochloric acid because it is below hydrogen in the electrochemical series, due to which it does not react to liberate hydrogen. But if you are giving a weaker acid, okay, if you are giving a sulfuric acid, then somehow copper get the strength. Copper from a complex reaction happen to copper, and somehow it can displace some amount of hydrogen gas. So this one you have to remember, that copper easily cannot react with hydrogen chloride or hydrochloric acid to displace hydrogen, but somehow if sulfuric acid is given, they can form hydrogen gas and salt. Okay, so this is a special case for copper. You have to remember why copper cannot react directly with all acid, because it is present below hydrogen in the electrochemical series. Okay, next type of reaction is reaction of metals with bases. Now same way metal react with base as well. So metal react with bases to give metal salt and hydrogen gas. But here you have to remember that this reaction is not true for all the metal. Only few metal will react with few bases to form the salt and hydrogen gas. Okay, it's not open for all. It's not an open category reaction, but it is exclusive reaction. So some metal they react with some bases, and what they form, if they react, they will form salt and hydrogen gas. Now one example is given here. Metal like zinc react with sodium hydroxide. Sodium hydroxide is what? Sodium hydroxide is an alkali. It's a water soluble base. So you'll take sodium hydroxide solution in a beaker, you'll add some zinc metal. What you'll get? You'll get a salt termed as sodium zincate with the liberation of hydrogen gas. So this is the overall reaction. In a beaker you'll take some sodium hydroxide, there will give some zinc metal granule. The reaction will happen to produce Na2ZnO2. What is the name? Sodium zincate and hydrogen gas. Now here to detect the hydrogen gas, what test you have to perform? Here also you have to perform the same pop test to detect whether the gas is hydrogen or not. Okay, so that is the reaction of metal with bases. One more example is given in this category. It is given with the reactive aluminium metal with sodium hydroxide. So how aluminium react with sodium hydroxide? See, sodium hydroxide solution will take, so solution will make in the waters, that's why this water is given here. So aluminium plus sodium hydroxide plus water, they will combine to form sodium aluminium hydroxide. See, one is plus, one is minus, so if you combine these two, you are getting one salt. Sodium aluminium hydroxide, it's a complex kind of salt, and it will also liberate hydrogen gas here. So basically metals on reaction with aqueous solution of bases, they are producing salt and hydrogen gas. So acid and base almost they react in the same way with the metal to produce metallic salt and hydrogen gas. But there also you have to remember few points, that all the metal and all the with metal, all the metal do not react with all the acid and all the bases in the same way. Now third type of reaction is the reaction of acid with metal carbonate and metal bicarbonate. So what is the other name of metal bicarbonate? Yes, metal bicarbonate is also known as metal hydrogen carbonate. Bi is the term used for hydrogen. Okay, now how it react? the reaction goes as metal carbonate. When it reacts with acid, they produce salt plus carbon dioxide plus water. Okay, so this reaction you have to remember, this format you have to remember. So metal carbonate plus acid, the product will be salt, carbon dioxide gas. Do remember, here is not hydrogen gas, here it is carbon dioxide gas, and the byproduct is water too. One example is given, Na2CO3. What is the name? Sodium carbonate. Sodium is a metal, so it is a metal carbonate. Sodium carbonate plus hydrochloric acid is forming sodium chloride salt plus carbon dioxide plus water. Okay. Another reaction is given for the second category. Metal bicarbonate plus acid is forming salt plus carbon dioxide plus water. So metal carbonate and metal bicarbonate both are reacting with acid to produce same kind, almost same kind of product. So NaHCl3 also, if you are taking, you are treating with HCl, here also you are getting same product. You see NaCl, carbon dioxide and water you are getting. Okay. Now, in both the reaction, what is common gas liberated? The common gas liberated is carbon dioxide gas. Now, you know how to test the hydrogen gas, but do we know how to test the carbon dioxide gas? Not yet. So, let's understand, or let's see how to detect the carbon dioxide gas if it is produced in any of the reaction. So, to detect the carbon dioxide gas, the test we performed is termed as lime water test. Okay, so for carbon dioxide, what is the name of the test? The name of the test is lime water test. Now in lime water test, what we do, we pass the evolved carbon dioxide gas, whatever carbon dioxide gas is produced in this reaction, this gas, if we pass through lime water, then we see that the lime water turns milky. Okay, the colorless lime water will become milky. The reaction goes like this. Okay, now lime water means what? Lime water, the formula of lime water is calcium hydroxide, CaOH whole 2. Okay, this number 1. Okay, in this test tube you can see some water kind of solution. The solution look like water is given here, and with a glass tube you are blowing carbon dioxide gas. Now this lime water, initially how it appear? It appear just like normal water, colorless, smellless, like that. Now when you blow carbon dioxide in it, a reaction happen. This is the first reaction happen. Calcium hydroxide plus carbon dioxide, it produce calcium carbonate plus water. Okay, now this calcium carbonate in the solution is a precipitate, that means it is insoluble in nature. Okay, so you're blowing carbon dioxide through this tube in this solution, then what happen? Due to the reaction, calcium carbonate will produce, and this calcium carbonate will make the solution milky in appearance, right? So from a colorless solution you're producing a fake milk. Okay, you're getting a fake milk solution. Now if you think that you'll blow some more carbon dioxide and you'll get some more milkier solution, then what happen? You see, carbon dioxide, if you're adding to this milky solution, if some more carbon dioxide you're passing to this milky solution, then another set of reaction take place, and here you are getting soluble calcium hydrogen carbonate. That means if you just keep on blowing carbon dioxide in the solution, then what happens? The solution again become colorless. Okay, if you're becoming too greedy to produce more milk, then what happen? You will be reaching on the same state again in the colorless solution, because on passing excess of carbon dioxide to this calcium carbonate solution, it produces calcium hydrogen carbonate. And how calcium hydrogen carbonate appear? It appear soluble in nature. You cannot see any precipitate after that. Okay, so that is the test for carbon dioxide gas. So carbon dioxide gas will pass through lime water. It produces white precipitate of calcium carbonate that appears to be milky in the solution. Okay, so for hydrogen, pop test; for carbon dioxide, lime water test. Okay, these two you have to remember. Next set of reaction is reaction of metallic oxide with acids. Okay, now see, Metallic oxides react with acids to give salts and water. Okay, that is very common reaction. How metallic oxide and acid react? They produce salt and water. Okay, let us consider the reaction. One example is given: copper oxide, metal oxide, copper you have taken, and you are reacting it with dilute hydrochloric acid. So copper oxide plus acid forming salt, copper chloride, and water. Now one thing is known to you. You know what is this? It is an acid. You know what is this? This is salt and this is water. So what plus acid gives salt and water? So what will fill in the blank? The substance must be basic in nature, because we know that when base react with acid we get salt and water. So four things are given, out of it three are known to us. So obviously you can detect the fourth one. So fourth one is what? The fourth one is our base. So we can say that metallic oxides are what nature? Metallic oxides are basic in nature. And we also know this one, metallic oxide we have tested with litmus paper earlier in previous class activities, that these are basic in nature. So same way the reaction goes, base plus acid forms salt and water. Metallic oxides are basic, so with metallic oxide, if you're treating acid, you will be getting salt and water. Next category of reaction, non-metallic oxide with base. You know what is the nature of non-metallic oxide? Non-metallic oxides are acidic in nature. One example given here is carbon dioxide. If you are treating this carbon dioxide with a base, calcium hydroxide, same thing you are getting, salt and water. So what will be the nature? Base plus acid forming salt and water. So this non-metallic oxide must be acidic in nature. So non-metallic oxides are formed by the reaction of non-metals with oxygen. We know how non-metal oxides are formed. You have to burn it in oxygen. They react with base to give salt and water. So this reaction is given, calcium hydroxide plus carbon dioxide forming calcium carbonate and water. Okay. The last type of reaction. So far we have seen how acid and bases reacting with different uh, materials or compounds. Okay, now we'll try to see what happen if we mix these two. Okay, if we are mixing these two complementary things together, then what happen? Now you know that acid is complementary to base. Okay, so what will happen if we mix these two? We can expect that they will neutralize each other. Okay, they will finish or they will diminish the effect of each other. Now what is the reaction? The name of the reaction is neutralization reaction. So when we mix acid and base together, then we expect a neutral product. Okay, neutral salt and water. Now see, acid and base react with each other to nullify the effect of each other. So both are opposite or complementary, so they nullify, they cancel the effect of each other. Okay, let us consider a example. We have taken sodium hydroxide base, and here we are adding few drops of HCl to it. Okay, in a base we'll be giving some acid. In the product, what you can see, we can see some salt NaCl formed along with water. Okay, so when you mix acid and base together, the product is what? The product is salt and water. That much for today. Thank you.